Dear children, in the last session we have learned about a measure of dispersion, which is mean deviation. Mean deviation, about mean and median we have learned. Now much more another important measure of dispersion we are going to learn in this session, that is standard deviation and variance. Variance is defined as, it is the mean of squares of deviation from the mean. That is, it is the mean of 1 by n, mean of squares of deviation from the mean. That is, from each observation we take the deviation from the mean. For each and every observation given in the data set, we take the deviation from the mean. So first we need to find the mean of the data set, then take the deviation from each deviation, square it, and then find the mean. And that measure is known as, or that value is known as, the variance of a given data set. This is the formula for a discrete ungrouped data. That means a data which does not have frequency along with the data set, ungrouped data. So again, once again, mean of squares of variance is the mean of squares of deviation from the mean, and that measure is known as the variance. Again, standard deviation. Standard deviation is defined as the square root of variance. So first we find the variance, we find the value, then by taking the square root of variance we obtain the standard deviation. And standard deviation or variance is considered as the most accurate measure of dispersion. There are another measures and not measures. There are another methods to find variance and standard deviation. The first we discussed for discrete ungrouped data. Next we are going to discuss for discrete grouped frequency distribution. That means a data with frequency given along with the data set. That is, standard deviation is given as, it is very similar to what we have done in mean deviation. If frequency is there, then frequency is to be multiplied with the squares of deviation from the observation. That is, the formula is given as variance is equal to, standard deviation is equal to square root of 1 by capital N. Capital N represents the total number of frequencies, that is, or the sum of frequencies, from 1 by n into sum of I from 1 to n, fi into xi minus x bar the whole square. N is given there, sum of frequencies. Then one other formula to find standard deviation. If the numbers are very big and calculations are becoming tedious, we can use one other formula to find the standard deviation or variance. Standard deviation is given as 1 by n into square root of capital N into sum of I from 1 to n, fi into xi square. That is, we square the observations multiplied with the frequency. That is fi xi square, and take the sum, minus sum of I from 1 to n, fi xi the whole square. That is, we multiply the frequency and the deviations, then find the sum and we take the square of that sum. So this is one other formula to find the standard deviation. Now, as we have learned in mean deviation, there is a shortcut method to find the standard deviation as well. That is, when the data observations are high, or for continuous data distributions, the observations may be very, very big, so that the calculations will become more tedious. Then we consider the shortcut method or the step deviation method to find the standard deviation, very much similar to that of mean deviation. Here x bar or mean we find using the same formula what we have discussed in mean deviation, that is capital A plus sum of I from 1 to n, fi yi by n into h, where capital A is the assumed mean of the data set, h is the interval width, and yi is given as, what is yi? Yi is given as xi minus assumed mean divided by h, where h is the interval width. Then the standard deviation using shortcut method, standard deviation is given as h by n, where h is the interval width, into square root of capital N into the same formula as before, sum of I from 1 to n, fi yi square minus sum of I from 1 to n, fi yi the whole square. That is, these two formula are very similar. See, look here, it is 1 by n into square root of n into fi xi square minus sum of fi xi the whole square. There we don't take the deviations because the values in the data set may be small. So calculations are maybe easy there. Then in those type of questions we can use this first formula, and when the data set is a big data set, that means when the numbers are too big, then you can go for the step deviation method. Only a very small change in the formula. Here you have h by n, and this xi will change as yi, where yi is the new value or the deviations which we have got. Yi is given as xi minus a by h, where a is the assumed mean and h is the interval width. So these are the formulae to find out standard deviation, and to find the variance we can square the standard deviation, or once we are finding the variance first, then to obtain the standard deviation we can take the square root of variance to obtain the standard deviation. And this is the last measure of dispersion which we are going to learn in this chapter. Now we'll discuss questions from exercise 15.2 how to find the variance and standard deviation, and as well as mean of some data sets. So we are going to discuss question number 1 now, to find how to find the mean and variance of this particular data set. Find the mean and variance of this data set. Xi is given as 6, 7, 10, 12, 13, 4, 8 and 12. That is a discrete ungrouped data set, and we know how to find the variance of the discrete ungrouped data set, that is 1 by n into, where n represents the number of observations, small letter n, into I from sum of I from 1 to n, xi minus x bar the whole square will give you the variance of this particular data set. So in order to find the variance, first thing we need to do is find the mean of the given data set. To find the mean of the given data set, simply add all the observations and divide by number of observations. It will give you 72 by 8. Sum of all the observations is 72 and the number of observations is 8, and the mean is obtained as 9. Now we have to take deviations of each and every observation from this mean, that is xi minus x bar. 6 minus 9 minus 3. In mean deviation we used to take absolute values, that means we didn't consider the sign. But here in standard deviation, or to find the variance, we are not considering the absolute values. Instead we are squaring it to get a much more accurate measure of dispersion. So 6 minus 9 is minus 3, 7 minus 9 minus 2, 10 minus 9 1, 12 minus 9 3, and similarly if we find all the deviations, square the values in the next column. Xi minus x bar the whole square. Minus 3 square is 9, minus 2 square 4. Similarly we find all the squares of deviations. Find the sum. Then straight away substitute in the formula, we get variance is equal to 1 by n, that is 8. 1 by 8 into sum of I from 1 to n, xi minus x bar the whole square. Xi minus x bars we have here, and the sum we have obtained it from the table, that is 74. So the variance is given as 74 by 8, which is 9.25. As I mentioned in the earlier videos, when we find out the values of statistics of these measures of dispersion, we have to find the final answer in decimal form corrected to 2 decimal places. Then next we will move on to question number 4. Question number 2 and 3 can be done at home. It is very similar for discrete data distribution, very similar method. Now for a discrete data set but grouped one, that means frequencies are given, we use this method. Frequencies are also involved in this particular calculation. So look at question number 4. Xi is given as 6, 10, 14, 18, 24, 28 and 30, and the corresponding frequencies are listed down. Now in order to find the variance, first we need to find the mean. You already know how to find the mean of a discrete grouped data. That is, mean is given as sum of I from 1 to n, fi xi divided by capital N, where capital N is the sum of frequencies. So sum of frequencies we found out it is 40. In order to find out the mean, we need the product of frequencies and the deviations, that is fi xi. So we find out 6 into 2 12, 10 into 4, 40, 14 into 7, 98. Similarly, all Fi, Xi's we have got, and the sum is obtained as 716. Now, we can find out the mean. What is the mean? X bar is equal to sum of Fi, Xi by capital N, that is 760 divided by 40. You will get it as 19. Then, same thing as before, in order to find the standard deviation or variance, you have to find the deviation of each and every observation from the mean. Xi minus X bar, that is 6 minus 19 minus 13, 10 minus 19 minus 9. All the deviations are taken, then square it. 30 minus 13 square 169, minus 5 square 25. Similarly, all the squares are obtained. Now, as frequencies are involved, you have to multiply these squares of deviations with their corresponding frequencies. That is, Xi minus X bar the whole square should be multiplied with their corresponding frequencies. So, 169 into 2, 338. 81 into 4, 324. 25 into 7, 175. 1 into 12, 12. 25 into 8, 200, 81 into 4, 324, and 121 into 3, 363, and we need to obtain the sum of that particular column, that is sum of Fi into Xi minus X bar the whole square. You will obtain it as 1736. Now straight away we can apply in the formula for variance. Variance is equal to sum of I from 1 to n, Fi into Xi minus X bar the whole square divided by capital N, where capital N is the sum of frequencies. That is 1736 divided by 40, it is 43.4. So that is question number 4. Now we will move on to question number 6. In question number 6, it is asked to find the mean and standard deviation using shortcut method. That too is for discrete grouped data. We have to use shortcut method. Shortcut method is used to find the mean. Standard deviation, also we use deviation yi. Yi is given as Xi minus A by H, where A is the assumed mean and H is the interval width. Here, interval, as it is not a continuous data, interval, see, look at the data set 60, 61, 62, 63, 64, etc. Therefore, the interval width H can be considered as 1. The distance between the first data set and the next data set is, next data point is simply 1. Therefore, H is considered as 1. Assumed mean, you can assume, take the approximate middle value. So, I consider it as 64, the assumed mean. Then the corresponding frequencies are listed down. When we take the sum, you will get capital N. You will get capital N as 100 or sum of Fi as 100. Then find the deviation or the shortcut method. Yi is Xi minus capital A by H. Assumed mean is 64. That is Xi minus 64 by 1. That is 60 minus 64 by 1 minus 4. 61 minus 64 by 1 minus 3. Find out all the yi's. Then to find the mean, you have to multiply the frequency with these deviations. As these numbers are bigger, that is why it is multiplication will become tough when we do Xi Fi. That is why we consider a yi, we use the shortcut method. So now multiply this yi with Fi, minus 8, minus 3, minus 24, etc. We will get Fi into yi. To find mean using shortcut method, this is the formula. X bar is equal to capital A plus sum of Fi yi by capital N into H. That is 64 plus sum of Fi yi, we obtain it as 0 here. 0 divided by 100 into H, the value of H is 1. So, the actual mean and the assumed mean is the same here in this question. X bar, we have got it as 64. Now, in order to find the variance, we need to find other values as well. Yi square, we need to find yi square. Square of 4, minus 4, 16. Square of minus 3, 9. Minus 2, 4. Minus 1, it is 1, 0. We have found out all the yi squares. We got the sum as 60. Then frequency into yi square. All the yi square terms is to be multiplied with the corresponding frequencies. So 2 into 16, 32. 1 into 9, 9. 12 into 4, 48. 29 into 1, 29, and all Fi yi squares are obtained and the sum is obtained as 286. Now substitute in the formula. Substitute in the formula, variance is equal to 1 by capital N. 1 by capital N into sum of I from 1 to N, Fi yi square, Fi into yi square, this is the sum, 286 minus sum of Fi yi the whole square. Sum of Fi yi, we have it as 0 here. So when you substitute 1 by capital N, 1 by 100, Fi yi square, its sum is 286 and minus sum of Fi yi is 0, so it is 0. 286 by 10, by 100, it is 2.86, the variance. In order to find the standard deviation, you have to find the square root of 2.86. We have already learned in class 10 how to find the square root of a number. So by using that method, you have to find the square root of 2.86 to obtain the standard deviation, and we obtain it as 1.69. Next, we are going to discuss question number 7 from exercise 15.2, that is how to find the mean and variance of a continuous frequency distribution using shortcut method. That is, the class intervals are given. That is where we identify the data set as continuous. Look for the intervals. If there is no gap in between, then we can straight away go ahead with the problem. If there are gaps between the intervals, you have to make it without gaps. So 0 to 30, 30 to 60, intervals are given and the corresponding frequencies are given. Whenever a class interval is given, in order to go ahead with the calculations, we have to find out the midpoints of the interval. So the midpoints, we name it as xi. 0 to 30, the midpoint is 15, 30 to 60, 45, 60 to 90, 75, and all the midpoints are listed down in the table. Now for doing shortcut method, we need assumed mean and we need to find the deviations, the step deviations, that is yi is equal to xi minus a by h, where a is the assumed mean and h is the interval width. So yi is xi minus 105 is the assumed mean I have chosen here, and 30 is the interval width. We find out the step deviations. We got it as minus 3, minus 2, minus 1, 0, 1, 2 and 3. Then in order to find the mean, we need Fi yi, that is all these step deviations we have to multiply with the corresponding frequencies. Minus 3 into 2 minus 6, minus 2 into 3 minus 6, all the Fi yi's we found out, and its sum also we have obtained. Now finding out the mean, it is assumed mean plus sum of Fi yi divided by capital N into h, that is 105 into 105 plus 2 by 30. 2 is the sum of Fi yi. 2 by 30 capital N into deviation, that is interval width is also 30. So these 30 and 30 will get cancelled down, and 105 plus 2, we get the mean as 107. Now in order to find the variance, what we have to do is yi square we need to find out, and Fi yi square also we need to find out. Yi we have all these values, squares are written 9410149. Then all those squares we have to multiply with the corresponding frequencies, that is 9 into 2. 9 into 2, 18, 4 into 3, 12, 1 into 5, 5, 0 into 10, 0, 3 into 3, 3 into 1, it is 9, 4 into 5, 20, and 9 into 2, 18, and in sum we have obtained it as 76. Now in order to find the variance, the equation is h square by n square into capital N into sum of I from 1 to n, Fi yi square minus sum of Fi yi the whole square. H square is 30 square, capital N is also 30 here, therefore it is again 30 square into n, 30 into Fi into yi square, we got it as sum of Fi into yi square. Look here, Fi yi square, its sum is 76. Wrote it here, n into Fi yi square minus sum of Fi yi the whole square. Sum of Fi yi we have it as 2, the square is 4. Therefore 30 square and 30 square will get cancelled. 30 into 76, we will get it as 2280 minus 4. The answer, the variance is 2276. That is how we find the variance and mean of a continuous frequency distribution using shortcut method. Question numbers 8, 9 and 10 are also being done using this very similar method. The last question, that is question number 1, there are gaps between the intervals. So what you have to make sure is initially convert the intervals in such a way that there are no gaps between the class intervals, then take the midpoint, and the same method, same formula, everything can be applied to do question numbers 8, 9 and 10. So that can be done as homework. And the next topic, analysis of frequency distributions and comparison, that is coefficient of variation, is a deleted portion this year. So with this variance and standard deviation, this chapter has come to an end.